Hello, everyone. Thank you for tuning in to our talk today. Welcome to the cellocamp Talk Series. I'm Rachel Jacob, Program Manager at cellocamp, and here with me on screen today is Deepak Nuli, founder at MultiSig and security at cLabs. He's also one of our cellocamp mentors, and he will be speaking about the security aspects needed to take into consideration when developing our dApps. You can ask any questions throughout the talk in the Ask a Question tab, and we'll have time at the end to address your questions. And Deepak, thank you so much for joining us today. And I will pass the floor over to you.
Thanks, Rachel. Before we get started, I just want to get the feel for what people are looking for in terms of security. So let's take maybe like a couple of minutes and just type in like a word or a sentence of what is the biggest pain point for you in terms of security, and then we'll get started soon. Securing user information. Or if you also have any specific questions, you can type it here, and maybe I can answer them when I'm doing the presentation. All right, let's get started. So I have one question here or comment. Securing smart contracts. Wonderful. Let me see if I can start sharing my screen here. All right, wonderful. So I'll minimize the window here. Preventing DeFi hacks from taking place, security tools for smart contract development, storing data at the backend is what our clients ask about. We store individual data on behalf of NGOs that serve them. Orgs like UNICEF need the data highly secure, for example. All right, cool. We'll cover all those things. Cool. Let's get started here. We have a lot to cover. All right, so I'll just quickly go over what we'll be talking today. So this is more of a survey kind of talk. So I will go over a lot of things that I think is applicable to dApp developers as well as node operators. It'll cover a whole gamut of things, but it can get overwhelming. But throughout the talk, I will give a little pointers of where you should be focusing on and what things that you should ignore. And also after this talk, feel free if you have more questions or any specific questions, we can also schedule a one-on-one to answer some of those questions. So what I'll do is I'll talk briefly about how to think about threat modeling, and that will be the starting point when you're thinking about security. And I'll talk about different types of security practices to think about and how they apply to different components of what you're doing. For example, how they apply to the software you're building, the infrastructure that hosts the software, and how you're doing operations within the company and your people, how to do key management. And the third part is we'll also talk a little bit about being ready, if some incident does happen, what things you should be prepared with before it happens. About me, a quick about me, I've been doing information security, mostly consulting for the last 12 years, started my career doing a lot of pen testing, then moved on to doing incident response and investigations. And currently I do a bunch of different things in the field of security, mostly doing security program development, where I go into a company, I help people think about what security controls they need to put in place, how they should think about building their security team, and different projects around security. And right now, I'm also helping cLabs with their security program development. Other than that, I love to travel. I've traveled I took a sabbatical for 2 years, went and traveled in the Amazons for 8 months. I was in the deep forest, which was fun. I also like to learn languages, speak a little bit of Spanish, Italian, and 3 Indian languages. And I also teach yoga. So if you're interested in that, I am hosting this Thursday's Cello Prosper. Please come for that as well. Moving on. So I just wanted to start with a small story to highlight what is important in security, right? So one of the clients I used to live back in New York, and one of my clients wanted me to test their physical security. So this was, let's call it a financial institution. It could be a bank, but I just want to, for the privacy of the client, just call it financial institution that controlled, or other banks relied on this institution to move a lot of money. And I had to break in, right, without knowing anybody in the company. So what I did was I spoofed my number. I called the security guards. I don't know if you know, in New York has the most strict security controls. There were like guards for the whole building. So I called the guards in the building, and I spoofed my number to look like it was coming from this financial institute. And I told them, hey, I have a guest coming. Why don't you put this person on the guest list? So they put my name on the guest list. So I show up on a Friday evening, just when everybody's leaving to go home. And the guard just prints me a visitor badge and lets me up. And then I go up to the company itself, but the company has high security, right? So they have a reception area, and then they had a bulletproof glass behind which another security guard was sitting, and there was like a man trap. And to enter that, you needed to scan your retina to get in, and also had to have a key card. So I show up, everybody's dressed in like a 3-piece suit, right? It's New York. And I show up in this torn jeans, t-shirt, and a baseball hat. And I find like the worst looking bag in the office that somebody had left. And I shout like some wires, screwdrivers, and a clipboard. And I called myself an electrical engineer. I don't know how electrical engineers look, but this is like my impression. So I show up and I open the clipboard and I start making notes. And the guard behind this bulletproof booth is like looking at me and like, what the hell are you doing? And I tell him, no, I'm here to do maintenance for electric appliances here. And he's like, oh, I have no idea like who you are, why you here. And I tell him, no, my boss told me the last minute, I'm really sorry. And the guy is like, I can't allow you without an email from somebody within the company. Then I show him this letter that allows me to go anywhere in the company. And it's signed by his boss, who actually made that policy, right? And now he's confused, like he doesn't know what to do. So I tell him, hey, why don't you call your boss, right? And then he calls the boss, and the boss says, yeah, let him in, give him whatever access he needs, right? The mistake he did was that he looked at my letter to find that phone number. So then he comes out, he scans his eyes, he uses his card and lets me in. And now I'm walking around in the office, taking pictures, looking at all the sensitive documents people have left in the office. And then I come across this door. So it is the door to this security operations center, right? Like, so this is the place where if you see movies, they have like these huge screens, they're monitoring everything happening, security stuff. So I want to get in. So I stand there to tailgate somebody, but nobody comes out. And I'm worried now because it's for Friday evening. And I see the guard walk towards me. I freak out. I think that the game's up, right? That this guy just kicked me out. And he comes to me and he asks me, do you want to get in? I'm like, yeah, sure. And then he scans his eyes again, scans his card, lets me into the operations center. And then there are 4 people. They all turn back and look at me. And now, because the guard is behind me, they don't question, right? The people who are supposed to be in there are just those people. And if the guard is there, it should be fine. And then behind the guard, I see that they have the whole data center within that operation center. And then I don't even have to ask him anything. I just point and he opens the door again. with his eyes and the key card, and I have access to the whole data server, and I even find a laptop that is unlocked connected to one of the servers. So I just take some pictures, take some proof that I actually could access their servers, and then I come out and I'd see how far I can push. I don't know if in the picture you can see, there's a poster behind. It says, "Do not take pictures." And I tell the guard, "Hey, you know what? Like my boss, I want to make him feel bad. This is my weekend, day off. He made me come to work. Why don't you take my picture?" And he takes the picture. Anyway, so the moral of the story is one, no, I didn't get the guard fired. I told them that, now he's learned his lesson. This is the best security guard you can have now, now that somebody's actually fooled him. And then second thing is, no matter how much security you have, the weakest link is always the people. So it's very important to train the people. I'll talk the rest of the talk mostly on technology, but it's very important to think about your people when you're thinking about security. All right, so as I said, we will talk a lot about different aspects about security from a high-level perspective. We'll not really go deeper into any of them. And then what is relevant to you will depend on what stage your project is at, and also the type of project. One caveat here is I do have professional experience in everything I'm talking about, but I have just a little limited experience around Web3 and smart contract security. But because of my experience, of course, I can still provide some feedback and advice, just so that you know. Take anything I say around that field with a grain of salt. Okay, so let's talk about a simple threat modeling. Threat modeling can get super complicated. It can take days and days to do. But to start with, I think you can just start with doing like a back of the napkin kind of analysis. Just do like a 1 to 2 hour workshop with your co-founders and maybe advisors to come up with a simple list, right? And how to do that, I'll just quickly show in 3 steps. One is identify. So when you're doing threat modeling, now you take off your hat as a developer or a CTO, and now you put on the hat of a security. Just you're looking at the same thing you built from a security perspective. So you create like a very simple architecture diagram that should show what are you building, what are the different components, and what are the interactions, right? So the interactions could be within your project, or the interactions could be with other dApps within the same ecosystem, or the interaction with the blockchain, things like that, right? I've given a very simple example here to make it understand. Let's say you have an app that allows a person A to send money to person B. A simple diagram could be A uses the app uses the internet to reach to the app server or directly to the blockchain, and then the app on the B side looks at this app server or the blockchain from the internet, and the person B can see the money that A sent. The next step is you want to enumerate. So enumerate a list of all the threats based on this diagram you just created, right? What can go wrong, who can cause it, and where can it go wrong, right? So some examples of threats could be the device that A uses could be hacked, right? It could be the phone, or it could be a computer that the app is installed on. It could have malware. Maybe the channel, right? The communication channel. Maybe A is using internet from a Wi-Fi at a cafe, right? That communication channel could be compromised. Maybe B is malicious, right? Or A is malicious. A can send the money. They say they send the money, but actually send it. So these are some threats that you can list. And then the third part is taking action, right? What are you going to do about these potential threats, right, that you just thought about? So you just bring all list of threats and then maybe categorize them based on different aspects. So it could be maybe data at rest, when the data is stored. It could be data at when it's moving on the internet or through the wire, and then make a priority of all those threats And then for each of those categories, you can have a few controls to protect them. For example, you can have antivirus scan on the device. Maybe you'll use your app or HTTPS to prevent man in the middle, and also use like something like certificate pinning to prevent a third party from taking advantage and creating like a man in the middle kind of attack. And maybe for the other part where A is malicious, you can just verify if they actually send that transaction on the ledger. So this gives a very simplified form of how you would do threat modeling, but it's a good starting point. It gives a good picture of how you can do this for your own application. All right, so now let's talk about the different types of security practices. For example, what are controls, what are audits, what are testing? Maybe you heard of these things, but you don't know like where these things fit in your own environment. And we'll talk a little bit more here. So what is control, right? So let's say you created all these threats and came up with a list of action during the threat modeling. So now you have to implement those controls, right? So that is just controls. Like you can configure settings maybe in your cloud server, or you could have to do some kind of engineering to secure the application or the infrastructure itself. So these are the controls. So for example, it could be, oh, we want to use two-factor authentication. So this is a control that you will set maybe in your cloud server that says, hey, every user that logs in, let's use two-factor authentication, right? Audits. So, and I also given here like the $ to show you how much time or money it would cost, right? Just to give you an idea of what each of these components will cost you. So audits are nothing but you're just verifying. Let's say you said the control was we want to use two-factor authentication. Now, when somebody's doing an audit, they'll just go and say, just go through a checklist and see, hey, we said we'll use two-factor authentication. Is it set up? So they'll just go to the console and see if it's set up. That is one control that they audited. Maybe the next control is we want to use HTTPS, and then the auditor can go and look at your app and see, hey, is HTTPS enabled here? And then they can checklist. So that is an audit. So the next part is testing. So testing is more involved than audits, right? Audits are just confirming. Testing is doing the actual test to figure out if whatever we said we're doing is actually being done. In this example, it could be just, hey, when I try to log into your application, will I see a two-factor authentication prompt, right? Maybe you put that control, but somebody else removed it. And the auditor, when they checked it, it was enabled. But when you actually do the testing, you find out that, oh, no, it was not enabled, right? So these are different aspects of security, right? You set the controls, you audit the controls, and you do the testing to validate that it was actually in place. And what are the different types of assessments that you could do based on these three things, right? One is doing this kind of assessment from an internal perspective versus external. Internal means that as an insider, right? What can the employees within the company do? That is called as internal assessment. That is like, let's say you have Google Cloud, GCP that you're using, and all the infrastructure within GCP, right? Maybe your servers, maybe your Docker containers, etc., are accessible only from the inside. So doing a test or an assessment from the inside is called as an internal test. And doing the test from the external perspective, right? As a user, they will not have access to any of these things. They'll not have access to your internal servers, but they can see the app, maybe they can see your website. So considering doing a test from that angle. So these are two different things when you're thinking about these things. And the other aspect of this is, how are we doing these assessments? Are we doing it internally in-house, or are we hiring a third party? This is a little more expensive. And another aspect of this is, how are these assessments being done? Are they being done automated way using an application that will just do some scanning, or is it done manually by a person who's actually doing these tests? So these are different aspects of the security assessments that you would think about. and what can be done, right? So we'll go for each of them. Let's say for the controls, who should be doing it? Ideally, you'd like to do it self. Like you should be setting up your security controls and doing security engineering of your app and the infrastructure. It's ideal that you do it and not a third party does it. And usually these controls are done on an internal side, right? You do all these setup on the internal. It doesn't really make sense to have security controls on the outside. Usually, again, it's done manually. Sometimes automated, like if you have a script that goes and sets up different like security policies, that could be done automated way. But usually you're setting up all these security controls in a manual manner. So audits, who does the audits? Usually third party. If you can't afford it or you don't have the time and resource, ideally a separate team or a separate person than who actually configured the controls. Is it done internally or externally? Audits are usually done internally. Is it automated or manual? It is both. Like you can do them manually or automated way. And for testing, it's similar, but you can do the testing both internally and externally. All right, moving forward of what should I be doing? It depends, as I said, like on which stage you are. When you're on the early stages of developing, I think you should definitely do your security controls after you do your threat modeling internally. Maybe just do self audits, right? Get a checklist, and I can guide you to what kind of checklists those could be a little later. If you have like some regulatory requirements, maybe you need like a money transmitter license, or you need other things, so you would still set up your security controls, and maybe you are required by law to do these third-party audits. But if you have a high-risk business, right? Maybe you're controlling access to a lot of money or a lot of crypto. Audits can only find low-hanging fruit. They're really not set up to find issues that could be interconnected when things interact with each other, and things maybe like interact with what third party has built. So in these cases, it's best to get a third party come in and do the testing. And maybe you are still required to do third party audits for your certification, but it's best to like do third party testing if you're running something like high risk kind of thing. All right, so now just moving on the software security itself. Maybe it's a smart contract, or maybe it's a web app, or maybe it is a mix of both. You have some Web 2 technologies and Web 3 as well. How to think about securing that. All right, so most of the things I talked about Web 2 applies to Web 3 as well, and with some external considerations on the Web 3 side. So for this, for the internal testing that you will do on the Web 2 side, you want to make sure you test the web application and its connection with like the database, with the web servers, with the storage that you have, and looking for any security issues within these interactions. From an external perspective, you would want to like get your website. If it's just a static website, you don't need to worry about it. But if it is like a user has to log into your website, then you want to get it tested for different aspects. And it's something similar with mobile applications as well, where you want to test different security things like input validation, looking at different privilege access that users have. Can they try to access other users' data and other things, right? You would make like a checklist and try to test all those things in terms of from the perspective of an external user, to make sure that they can't do anything malicious. And again, like a good philosophy about security is, it used to be much easier to do security in back maybe like 10 years or 5 years ago, where you used to use this whole waterfall model where you gather your requirements and you build your whole software. It takes 6 months or 1 year, and then you come, and then the security person is the gatekeeper, and they will do the security, and they'll give you a checklist and say, yeah, you're secure, or go fix this, and you come back, right? But things have changed now, and what we call as like shift left security. So what with the whole like continuous integration and continuous deployment, we're not doing that anymore, right? So we're doing like deployments every other week, maybe every month. We're creating like these new versions, but that also creates the challenge of doing security, because let's say you get audited or tested at point X in time, and then you made like more changes after that. It's really hard to use that old test that you did as a proof that you're secure now. So you don't know what is happening now. So the best way to be most secure is educate your engineers, do security early, and try to create steps within your CI/CD pipeline to find these security issues early on. All right, so so what are the different types of security testing for software, right? So the first one is called dependency testing, or also software composition analysis. So basically what this is doing is that it is looking at all the dependencies that your software has, and then testing if those software have known vulnerabilities, right? So this is pretty automated. You can just put it in your CI/CD pipeline, use like one of the applications out there. There are a lot of these applications out there. Again, it depends on what your project is and what modules you're using. So there's one example I can think of is like a tool called Sync. This is pretty fast. And when you set it up, you can set it up so that your CI/CD pipeline actually fails, because it usually has true positives when you run this. And then you can fix it and then rebuild your application. The next part is credential scanning. So basically what you're doing here is scanning your whole code base. Maybe you're scanning all the test documents you have in your like GitHub or GitLabs or whatever you're using, to look for any passwords that are stored during testing. Maybe you stored like some RSA keys, public PKI keys, or maybe some your cryptographic keys. So it just looks for those keys and searches and finds it. So you can again like make this as a failing mode in your CI/CD to once you find them, remove them, and then you can rebuild your software. And the next part, as we go down here, it gets more and more time intensive and costly. So the static application testing is basically you're doing an automated test here again, but now you're testing your own code, right? You're not testing your dependencies. Maybe it does some of that as well, but mostly you're looking at your own code to see if there are any like vulnerable functions that are used, or you're doing any like, I don't know if there was like any like memory related programming to find some issues within the way you're handling memory. But the caveat here is that static application testing, in my experience, create a lot of false positives and a lot of noise. So you would usually set this up in a non-failing mode so that your CI/CD pipeline still passes, but you still need like one of your devs to go look at any of the issues that are critical and fix them before you deploy your application. And the last part is dynamic testing. This is the most expensive one and time-consuming one. Sometimes you can also do some automated dynamic testing. So previously, we didn't actually run your code, right? It was just looking statically into your software. And this part is dynamic, as in you're actually running the application, maybe in a test environment, maybe in like a live environment, but not advisable. And then seeing like, okay, what are the interactions, like an actual like hacker looking at it and trying to see what they can break or what how they can exploit something that is happening in there. This is a slow process and it has a lot of true positives. So this is a very key thing to help you give good signal about any issues within your application. Briefly want to also touch upon smart contract security. As I said, everything with Web 2 applies here. In this case, there might be additional things. Again, we did like the architecture diagram during threat modeling, looking at relationships between different components and creating tests, right? Especially it's hard because it's a good thing with the whole Ethereum and UEM and the blockchain is that it's very highly composable. The bad thing is then you have a lot of these dependencies that you need to think about, these interactions with other apps. So making it really clear and detailed about how these relationships are occurring and trying to see how you can test and break based on that. Again, for this, you can also use like some automated scanners that people have built. Consensus has this page with some security smart contract best practices and security tools. You can look at that. You can also get third-party audits. I've given some examples here. Again, there's just examples. I have no association with any of these companies. And yeah, so this is what we would, some of the things that you think about doing for smart contract security itself. And let's move on to the infrastructure side of things. Before that, maybe I'll take 5 to 10 minutes and see if there are any questions that came up. Okay, so there's a question that says, as the case for Bitcoin, BTC transactions with zero confirmation can still be reversed. So my question is, in terms of Celo, once the payment is detected on the address, should we still worry about the confirmation? Okay, this doesn't apply to what I'm talking about, but maybe I'll answer that in later on if we have time. Any questions so far from what I've spoken? I'll just give a minute to see if there are questions. Otherwise, we can continue on.
There are some questions in the chat.
Oh, let's see here. Security tools for smart contract development. I shared some resources for that. Preventing DeFi hacks from taking place on Celo. Again, I think we're still early on. We don't have that much of an ecosystem here yet. And we'll start to, I think as we grow, we'll start building some of those processes in place to help mitigate some of those risks. Again, as I said, like building that a good threat model and looking at all the interactions you have with other third parties and doing this like early on and getting your code audited are some ways to prevent things like pickle hacks happening, storing data at the backend. So this is, I'll talk about backend data storage in a bit, and how to securely store private keys so that I can securely store customer data. I'll talk about that in a bit. I'm getting heavy echoes. Looks like that got fixed. All right, wonderful. I don't see any other questions. So I will move on to talking about the infrastructure side of things here. So what are infrastructure? So infrastructure is nothing but servers, maybe containers, cloud functions that is helping you run your application. So the other thing that we need to think about with infrastructure is how your developers are accessing this infrastructure, and do you have the right security controls in place to access and also manage your infrastructure. Okay, so what are some things that you can think about? So one is having internal controls within your infrastructure. So making an architecture review just about your internal like deployments. Maybe you have like some virtual machines, you have containers using, you have Kubernetes and cloud functions, maybe you have some storage blocks, all these things, right? Like making an architecture diagram of how the internal setup is done, and also making sure you're giving least access to people, right? When you have a developer, do they really need like super admin privileges to your cloud. If not, just creating roles and giving them exactly like what they need. And also creating a separation of projects. Do you have multiple projects within your company? And if so, do they really need to be on the same access level, such that, let's say, one of the projects gets compromised, making sure that other projects on the same backend don't get compromised. So keeping that layered separation, and also making sure that you have controls or some kind of service to prevent uh, from any distributed denial of service attacks happening on your infrastructure. So again, how can we audit this, right? You created these controls. So internal audits can be done based on a checklist. For example, for Celo and cLabs have created a validator checklist. So you can use this. So we use this to audit the validators on the Celo ecosystem. But this is generic as well. So some of these things can still apply if you are a dApp developer and you're using any of the cloud infrastructure or a data center to host your some parts of your application. You can still go through this. Created a link, and I will share this slides with Rachel afterwards, and she can email all of you with this. So you can go to the link and look at the checklist and see what applies to you, and you do a self audit and apply those controls to your internal stuff. From an external perspective, I think if you're early on in your project, you don't really need to get like third parties to come and audit your external infrastructure. A simple way, maybe like a starting point could be just doing a simple network scanning. Just use like a tool like Nmap to scan your network from the external side to see what other things are being exposed on the IP address that you own or the domain that you own, just to see what external entities can see and fix them. So this is a very like low-hanging fruit, easy way to do something. And again, access, like how is the access being managed to your infrastructure? Are you using a SSH? So if you're using SSH, making sure that it's not just password based, making maybe it's like a certificate based authentication. Maybe you want to set up even like a two-factor authentication there. Are you using VPN to log into your infrastructure? That's another way to like secure access. Maybe you should be on a certain your own self-hosted VPN to or a jump box to get into your infrastructure. And how is the access managed to the VPN itself? Having maybe a hardware-based second factor like YubiKey to provide you access over there. And I think managing your infrastructure is as critical as managing your own like smart contract security. If this applies, right? If you're just everything is decentralized, everything is on a smart contract, then you have to just focus on that part and testing. But if you, I've talked to some of you at CelloCamp, and some of you are having like a mixed kind of architecture, and you're using cloud, then an equally important part would be to secure your infrastructure itself. And the third aspect of security would be, first was the software, that we looked up software, and then we looked at infrastructure, and let's talk about operational security itself. So what do I mean by operational security? I mean, like, how are you doing key management? That is one part of it. And the other part of it is just generic corporate security, right? Like, how are your users or employees using their laptops? How is the browser security being done? What are the communication channels that you use in your company? And also how to think about all these like logins and how to manage the passwords that give you access to all these different kind of infrastructure that we have. All right, so first part is, again, like when you create your programs or applications, you tend to use a lot of these environment variables, making sure that your keys are never out in the clear text, right? So sometimes people store these keys as environment variables in the clear, which is not really good because what is it called? Because a lot of times, you might get hacked in different ways. And let's say somebody gets access to your cloud infrastructure. If all these like keys and are protected, then people don't really get access to them. If they're in the clear, then somebody can just read the environment variables and get access to them. So some ways to protect those would be all the cloud providers have something called as KMS, key management systems. So basically, this is something like a key vault that you use to be able to programmatically work with the keys that you need during your execution of your program. There are also third-party vaults like HashiCorp that you could use that can work across these different cloud applications and infrastructure. And on the Web3 side, right, how do we do operations of using multisigs? So you can have a multisig for your smart contract as like, or you could have multisigs for the assets you own. So this is important consideration to think about when you're doing the M of N multisig, making sure of two things, right? That N should be big enough so that you have enough redundancy in your structure, so that if, like, let's say if it's just 2 of 3 multisig and 2 people lose their keys, then you're like out of luck, right? So making sure that N is big enough, and also making sure that M is not too small, right? To prevent from insider threat. That maybe if it's like 1 of 5 multisig, it's not really great, right? Because one person has control. Or even if it's like 2 of, let's say, 10 multisig, then again, like 2 people can collude, and that has a high chance. So having like this, the right balance between M and N would work, right? Again, like there is no strict number that I can give you because it depends from company to company. So usually like a 3 of 5 is like a good like number. Again, it varies, but I would consider like 3 or 5 or maybe 2 or 5. If you're a small company, that is a good starting point. Again, hot versus cold wallets, right? What does hot mean? Hot is something when your wallet is on a device that is connected to the internet. Cold is making sure that the private keys to the wallets are never touching a computer that connects to the internet. How can you do cold storage? So you can do cold storage just by writing it in a piece of paper, maybe using a hardware key. But you do still have to somehow sign things, right? So maybe you need to use a laptop. So the most secure way of using a laptop or a computer would be creating this a dedicated laptop that never touches the internet, right? One has no chance of touching the internet, like maybe just disabling or just removing the Wi-Fi card itself from the computer, and not having cameras or microphones on these devices. This is like the most secure way. So what you would do is you would maybe have a USB key. Again, maybe that could be encrypted, plug it into your highly secure laptop, which has the keys on the laptop itself, or maybe another USB key that has never connected to the internet has these keys. And then you do your have the software that you need to sign these transactions on this computer. You sign your transaction, copy the transaction onto the USB key, bring it back to a computer that is connected to the internet, and then propagate that to the blockchain. So that is the most secure way, but again, it has a lot of overhead, a lot of coordination challenges, right? A moderately secure way of doing this is using, I call it shared laptop. It's not a laptop that is shared with your colleagues, but maybe it's a laptop with a dual purpose. Maybe I should reword that there. So maybe you have a personal like work laptop that you use. Maybe you use a USB to boot into like a bootable operating system, something like Tails, a Linux-based operating system that doesn't really connect to the internet. And then you use an encrypted key, again USB, to do the same thing that we did in the previous step. but using the same laptop that you use for other things. A less secure way, but still more secure than just using your computer to do everything, is to just have a virtual machine. You can use something like VMware to install a virtual machine on your computer, and then preventing internet access to that virtual machine, but still having access to the data on that virtual machine through through like a shared folder, or maybe just through USB, right? Even though the VM is running on your computer, not even letting the VM access to your own drive, but just through the USB, you can interact that way. It is less secure, but it's fast, it's easier, but much secure than just directly using your own computer that you use to do a lot of different things to manage the keys. All right, so moving on now to just the operations. This applies to just your corporate security. So laptops are the most important thing that you and your employees have. So making sure you have full disk encryption on the laptop. Nowadays, all the operating systems come with full disk encryption natively, like File Vault on your Mac. And I think Windows, I forget the name what they go by, but they also have a full disk encryption option. Linux now makes it like super easy to enable full disk encryption by default. Other things to think about is cover the camera, of course, your microphone as well. This is both for privacy and security as well. Whenever you're using your laptops, making sure that you create separate admin and non-admin accounts. And whenever you're using it, make sure that by default you use your non-admin account to do most of the work, and use admin account only when you have to install applications and make any changes to your laptop. This is like a really key thing to remember is one of the easy, as I said, right, social engineering is like the easiest way for somebody to like hack you. They can send you like a phishing email with like some malicious link. You click on the link by mistake. Like I've made the mistake. I've been in this industry for a while. Even I make such mistakes. Sometimes I click on links. So if you are running a non-admin account, that the access that hacker would have once you click that link would be minimal, right? If you are running as admin, then they have admin access to your computer. So that is one easy way to circumvent that one issue there. Also, any software that you install on your laptop. Of course, this is not possible for everything out there, but for at least the critical software, making sure that you verify the PGP signatures of the software developer, or if that is not available, doing a SHA-SUM of the software. One thing that I also like to do when I'm actually working with a lot of like these crypto related what's it called, wallets, is I usually Google search the wallet name. Let's say I'm using Electrum wallet for my Bitcoin. Somebody asked a question about Bitcoin earlier. I would not only verify this like the signature of the software, I would also look at the version and make sure that I check that version is the latest version, and also maybe go to the Twitter. Like a lot of times I've missed from making a mistake by looking at Twitter. On Electrum, I remember there was like this issue, and then people are already posting on Twitter, so I could see, oh yeah, like there's an issue, like I should stop, avoid using it, or update my software before I actually use it. The other important key thing is the browser security. Your browser is now like as powerful as your laptop, so it's really important nowadays to lock it down, really. So one thing is to just have the minimal amount of plugins installed on your browser, and here are some things that I recommend, and just keeping it as low as possible, right? Any plugin that you install is literally a backdoor into your computer, right? The plugins usually have all access to your browser, and you do most of your work on a browser these days, and it gets access to everything. So just being really cognizant about what you or your employees, the kind of plugins that you install. Going down to communication channels, is encryption required for your email? Are you worried about this part? So you could use something like SMIME or PGP to do email. There are also plugins. PGP is a little hard to use, but there are some plugins like MailVolop that allow you to do easy email encryption with PGP, using tools like Signal or Wire on your phone to do encrypted communication. Again, we already talked about multi-factor authentication. Also having a secure password manager, right? You should never keep, even if you're using a, what's it called, a cold wallet that you're using on a laptop that never connects to the internet, even when you're doing that, make sure that all the keys are always secured and encrypted. So the safest way to do it is using like a hardware-based password manager. Again, what you're doing with password managers is you're making sure that you have different passwords for each and every account you have. That way, if one account gets compromised, that doesn't compromise your other accounts. So using hardware wallet is the safest, but it's like hardest. I like to use a file-based file manager. Example is like KeePass or KeePass XC. Both are open source, and these files should be kept on like a device that never touches the internet. And then the easiest way is using a cloud-based password manager like LastPass. I love using Bitwarden as well. This is again, LastPass is owned by a company, but Bitwarden is an open source tool and it's really user friendly. I love using that. So using a bunch of these based on your threat model would work. And the last part I want to talk about quickly, like is incident response readiness. What does that mean, right? So like one of my previous CEOs would always like to say, getting breached is not the question of if, but when. So at some point in your career, the company you create or you work for will get breached. That's just the nature of how things are. But what are you going to do when you get breached, right? Having that plan in place before you get breached will really help you up your game, because if you get breached now and you have control over millions of dollars, then you freak out, you get emotional. So to avoid that, make a plan beforehand. So one is you want to store logs everywhere on your cloud, web servers, database, any other component that you use. Usually you want to store what are the things that you want your logs to store is who did what and when, right? So who's the user, who took the action, and at what time. So this is really important to help you investigate later on. So a plan could be really like simple, right? To start with, if you get breached today, who are the stakeholders you have? Do you have all the contact information of how to reach them? And also having some security experts and retainers in place before you actually get hacked, so that when you get hacked, you already have like experts you can call. Hey, I need help, and they'll be there for you to help you out. Again, like it doesn't have to be detailed. You're just beginning. Just having these things at the back of your mind and having some plan in place is really helpful. And again, as you proceed further and you mature, maybe creating like tabletop exercises where you simulate that you got hacked and what are the steps to take is a good way to proceed from there. And that is all for the talk that I had prepared. This is like my contact information here if you want to reach out to me. And let's open it up for any questions. All right, so one question was, what are secure ways to store addresses and its private keys apart from a database? Yeah, I kind of answered that question. So a good way to do it is use your hardware wallet. If not, then use things like KeePass or KeePass XC and store that on an encrypted volume. So even though like I have my laptop with full disk encryption and I have KeePass itself that is encrypted with a passphrase. So what I like to do is I like to create encrypted volumes. So you can use a tool like VeraCrypt to encrypt volumes and then put all the external keys like KeePass on that encrypted volume. That way, even if like let's say you're going through immigration at an airport and the border security asks you to unlock your laptop, sometimes you are required to unlock it. that way you're still safe because you have an additional layer of encryption on your device to protect whatever sensitive data that you own. Okay, so again, like the question about Bitcoin transaction, again, like I'm not a blockchain developer, but from my understanding is it is final. Like once transactions on what's it called, Celo are confirmed, then it's final. There is no going back. Like in Bitcoin, where you have to wait for 6 blocks. All right, so I don't see any other question. Let's see here if I missed anything from. I think I kind of covered all the questions. Again, like question about storing data at the back end when NGOs ask for it. Yeah, so you want to make sure that your computer where the data stores itself has full disk encryption. You want to make sure that if you're using any of the cloud providers, any block storage that you use have full disk encryption on them. Those are some ways that you can remain secure.
Okay.
And we have about 3 minutes.
Well, thank you, Deepak, so much for this insightful talk. If anybody does have any further questions, you can reach out to Deepak. I know I definitely learned a tremendous amount from listening to you today. And I want to thank everyone for joining us and who participated in the event. We welcome you to also join us for our Idea Fair, which is cELOCamp's demo day on December 8th at 8 a.m. PT, where our 7 cELOCamp finalists will be presenting their products built on the Celo blockchain in front of a live audience, including investors, experts in the field, and our panel of judges and the Celo community. You know what, I'll post that link right now. And I also wanted to let you guys know about our YouTube channel where you can rewatch this talk and other cELOCamp events as well. And on that note, thank you everyone for joining us. And Deepak, that was really wonderful. And we hope to see you again soon.
Yeah, thanks everyone. Thanks for joining, and feel free to reach out to me. I know it can get overwhelming. There's too much data that I share, but it's not about doing everything, just doing what is relevant to you. So feel free to reach out to me. I can help you figure out what is relevant and what is not.
Thank you. Have a good day, everyone.
Thanks.
Bye.
Bye. Thanks.